Hello everybody, I'm Jeff Wenzel. I'm a member of the Connecticut Hemp Industry Association, or CHIA, and welcome to our first video in a series of videos that we'll be sharing over the coming months. CHIA is a nonprofit member organization that supports Connecticut hemp farmers, processors, manufacturers, businesses, retail outlets, and consumers. And we do this through hemp advocacy, networking, education, and by showcasing our members. Today we're at Long River Farm in Old Lyme, Connecticut. We'd like to thank Walker Potts and the Long River team for having us. And today we're very pleased to have a guy that I consider a state treasure. He's been a major contributor to statewide efforts to increase farmer access to land, develop farm-friendly municipalities, and to promote locally grown and produced food. Kip speaks and teaches extensively statewide and nationally on soil quality, soils and land use planning, wetlands, farmland protection, and the rental and leasing of farmland. So today we're going to talk about soil, and we're thrilled to have Kip Kolesinksas joining us. Yeah, so Kip, thanks for joining us today.
Thanks for the opportunity. I'm always interested in talking about soils, and to me, anybody that's growing stuff, whether it's out of doors or in a high tunnel, they really need to consider the soils, the soils and the soil landscape and the setting to be most successful. Because we have.
Kip, I know we've spoken in the past about the Connecticut River Valley, which has some renowned soil and kind of a unique microclimate. But can you help us understand what makes the Connecticut River Valley unique and how it came to be?
Sure, yeah. Again, we have one of the most complex soil landscapes in the United States, and it's a combination of the bedrock geology and the way that the glacier moved through the state. So if we go back to 250, 300 million years ago, when Pangea, the supercontinent, was breaking apart, and as it pulled and stretched, and before Africa broke off from the mainland, it created a huge crack in the earth. And so that's the Connecticut Valley. It's actually a rift valley, like the Great Rift Valley in Africa. So there were volcanoes. It was all closer to the equator. There were volcanoes, there were huge mountain ranges, and then over millions of years, and the dinosaurs were running around because it was tropical. Mm-hmm. So you had these red sediments of colluvium, stuff that washed down the slopes, floodplains, swamps, marshes, and over time those ended up turning to rock. So when the glacier came through and ground up that material and then laid it back down, the meltwaters washed over it. So that's why along that whole 91 corridor central part of the state you see these reddish soils. Right. And one of the things that's unique about those is that they have a lot of micronutrients, a little higher base saturation. They can be a little bit siltier, a little bit clayier, so very productive. And then because of the glacial meltwaters, there was blockage at Rocky Hill and Cromwell, Middletown area as well, and formed glacial lakes. So the biggest one was Glacial Lake Hitchcock, which went from basically Glastonbury all the way up into Vermont and New Hampshire in the Connecticut Valley. So this was a glacial lake. So silt and sand came in there, filled in. The deeper parts are clay, the edges are sandy and silty. And then about 12,000 years ago, that glacial lake emptied, and then there were winds that blew through there and formed dune deposits of sandy materials. There were deltas where the ancient Farmington River came into the lake, so you had the big sand deposits there, kind of, southern part of Suffield, Granby, Windsor Locks, and then dune formations over in East Windsor, parts of Enfield. And then as the silts and the finer materials blew all the way over into like the Ellington Valley in that area, so you have what are called loess soils or loose soils, which you hear about in the Midwest as being so productive. We actually have loess or loose that covers some of our soils in Connecticut. So we have some very, very productive kind of what we call parent materials that the soils have formed in over the last 16, 17,000 years. And then on top of that, because the Connecticut Valley geologically is wide enough and deep enough that it has its own microclimate. So it's a little bit warmer, a little bit more humid than the rest of the state. So that's why it was ideal for tobacco production.
Right.
And actually one of the first soil surveys or inventories of soil resources in the United States, done in 1899, was done in Connecticut and the Connecticut Valley to specifically look at areas to expand for tobacco production. And so that's kind of the basis of some of the knowledge that we have about the soils in Connecticut from that 1899 survey. So we have that Connecticut Valley, which of course has a lot of development pressure, unfortunately, but it has a very high concentration of excellent agricultural soils with a microclimate that's very well suited to a warm season crop like hemp.
Wow, very cool.
Yeah, it is.
So where can people find information about their soil? Short of, digging some up and
Right.
bringing it for analysis. Are there any
Right.
resources or anything that people can look to?
Sure. So the first place that I would start if you're looking at a piece of property and its suitability for agriculture, suitability for hemp production, is the Web Soil Survey. So the Web Soil Survey is an inventory that's been done across the United States. There's soils information for about 95% of all private lands in the United States. And it's available through a digital format online. So if someone were to Google Web Soil Survey, and then if you have an address that you can put in, or as close as you can get to where the address is, put that in there and follow the routines, and you can create a soil map and look at some specific properties like depth of water table, slope, how sandy silty clay it is. Those are some really important features to look for its suitability for hemp production. And then nothing beats an on-site investigation of actually, getting somebody that's knowledgeable about the soils to come out and verify the soils, and then take a look at them, either confirm or deny what's on the soil map, because it's a planning tool, and about the minimum area of different kinds of soil that can be shown is about 3 acres in size. So it's always possible that you could be in what we call an inclusion of something that's a little better, something that's a little worse. And it's not unusual for a typical Connecticut field of 5 to 7 acres to maybe have 2 to as many as 4 different soils in there, which might have to be managed differently.
Right.
So then, come out there with somebody that's knowledgeable about the soils, take a look at it, see is it really what it is. And then the other thing is too, I would certainly recommend that people start out with a baseline of getting a soil test.
Sure.
So you're going to be interested in general, my understanding is that hemp likes sandier soils and well-drained soils. Well-drained from a soil scientist perspective means that the water table is not close to the surface during the growing season. You want at least 2 feet of soil material that's not going to be saturated during the growing season. And so water's going to drain through it pretty well. So thus sandy soils, water drains through them better. And you're going to want to have a soil pH of probably between 6 and 7. Doesn't like it too acid. And then when you get to more of the extremes, below 6, above 7, you can start to get some nutrient deficiency issues. And then again, if you have a soil test, you have a baseline that then you can use for your fertilization. So at least every 2 years you should get a soil test.
Very cool. Awesome.
The other thing that I would say too is that one of the things that I've heard is that the hemp plant does not like compacted soils. So that our sandier soils tend to not get as compacted as easily as siltier clay soils, because the pore spaces are bigger between the particles. So I think it's always important to stay out of your field when it's wet. Don't be bringing equipment on the field when it's wet. Also there's a possibility you can transfer soil-borne diseases and things like that. But you know, you're going to constrict the spaces, and it'll be harder for the roots to do what they need to do to get the water and the nutrients that they need. So try to not be walking around the plants, and reduce field traffic in the fields. Keep it nice and loose. And then also having your organic matter level up there, so you can get that by asking for that in the soil tests, because organic matter can act kind of, not only acts like a cushion to prevent compaction, and it also holds moisture. For every 1% of organic matter in the soil, that holds another inch of water. So again, just coming out of a short-term drought, we know how critical it is to be able to maintain soil moisture in the soil.
Very good.
So the soil right here has a nice kind of fine sandy loam texture, USDA textural.
Right.
So it would drain well, but hold enough moisture. But and then with depth, again, hopefully you'd have at least 24 inches of nice sandy loam material. If it's sandier or gravelier than that, that just means it's more prone to drought. If it has evidence of a seasonal high water table, you start to see orangey colors, gray colors. Those are indications of a fluctuating seasonal high water table. If you're in a soil like that, what we would call maybe a moderately well-drained soil, seasonal high water table of 18 to 24 inches, one of the things you can do when you're developing your planting scheme for your layout of your plants is to actually do them in slightly raised beds. So if you had a bed maker, you know, even if you can get it up an extra 6 inches, it's going to stay a little drier, it's going to stay a little warmer. And that's the other thing is too, which I'm sure, you know, as far as people are always asking, when to plant, when to harvest. And one of the things that's certainly critical in any warm season crop is soil temperature. So pay attention to the soil, your last frost-free period, your last frost, and to me, I would like to see soil temperatures at least 50 degrees before you're planting your starts.
Right.
Or your seed.
Yep. That makes sense. So we're down here at, you know, the just about the southernmost part of the Connecticut River. Do you think the soil would vary greatly from, you know, some of the farms up north in the state, you know, where they grow a lot of tobacco? Is there a huge difference in soil, or is it pretty similar?
Yeah, I would say, you know, typically, not that we don't have some larger areas of soils with sand and gravel deposits and kind of a loamy or sandy cap, but in general, in the lower part of the Connecticut Valley, you tend to have, which, you know, kind of in back of us here, has a lot of bedrock close to the surface.
Right.
So not that there aren't areas of quality deep soils, but they tend to be stonier, which means loose surface stones, or rocky, which means that it's attached to bedrock. So that's another reason to check out the soil survey. Yeah. Stones, surface stones, you can remove. If it's shallow to rock, you know, either you're going to be breaking equipment or the soil is going to be so shallow that it doesn't really offer sufficient rooting depth to the soil. So in general, you know, your best areas of what we would call prime farmland, the best of the soils, they're concentrated in the upper Connecticut Valley. They're concentrated in these areas, what we call drumlin fields, which are areas where the glacier kind of went over the top of the material that it laid down and created these low kind of cigar-shaped hills. So Woodstock, Pomfret, Lebanon, Franklin, Bethlehem, Litchfield Hills area are some areas where there are also concentrations of prime farmland soils. So, but you do have, what's interesting down here is that you know, we talked about microclimates in the Connecticut Valley, but we also do have very complex microclimates throughout the state. So the fact that you have this maritime influence here close to the coast is significant. It's just that it's a little bit of the opposite. It's chillier early in the season because Long Island Sound is cold, and it stays warmer later in the fall. So as you're thinking about your you're planting and growing and harvesting, you need to keep that in mind. But you're going to have probably fewer, above 90-degree days down here than you are farther north in the upper part of the Connecticut Valley. So that's also the thing is too. And when you get to, the northwest corner, the northeast corner, kind of what we call the Worcester Plateau up there in northern Talon County, Union, that area, your growing northern part of Woodstock, your growing season there may be 120 days. The middle of the Connecticut Valley, down here along the coast, your growing season may be 200 days.
Right.
So it's important to keep that in mind as well.
Very cool. So the next guests that the next video that we're going to share, we're having a couple of people talk about regenerative farming and sustainable practices.
Right.
And obviously, it's largely about building soils and building healthy soil, with an eye towards natural and organic practices,
right,
as much as possible with pest management requirements. Yep. But these guys make a pretty good case for hemp as an environmental solution. Mm-hmm. I know we're not a huge farming state, but does that make any sense?
Yeah, I would say, one of the keys to regenerative agriculture and sustainable farming systems, organic production, and also I think adaptation strategy for climate change is diversity. So diversity of crops. So that means, having a farmer, not only the varieties that they may grow of a certain crop, of have diversity of that, but diversity of crops, so that you're not going to get a buildup of soil-borne diseases, of insect pressure, those kinds of things. So I think it's important that it can be an important part of a rotation, because it has, and also it has a different rooting structure, it has different kind of microflora that are associated with the plant and the root system. So I think there are reasons for that as well. So and also I know that there's some discussion for hemp as a potential crop that could be used for remediating soils, that apparently has the ability to take up some contaminants. So, obviously it might be something that might be used in restoration of a contaminated site. I'm not sure exactly, from a product standpoint, whether or not the fiber would still be usable or not, and some of those kinds of things. Right. But I think that's an intriguing idea as well. And then, of course, I think the other thing is that some of the benefits, some of the properties that they talk about, and management and practices for regenerative agriculture are very beneficial to having a healthy plant. So if you have a healthy soil, you're going to have healthier plants. They're going to get the nutrients they need. They're going to get the water that they need. You're going to have more beneficial insects and microflora in the soil associated, so it's less likely to have diseases. So using cover crops and green manure crops and tilling less and mulches on the surface are all good ways to protect the soil, because we have these more intense rainfall events. We want to get the water into the soil. If you have a sloping site, you don't want to have erosion, because you're losing your topsoil, you're losing your nutrients, and you can get crusting, which makes it harder for seeds to germinate and for roots to grow. So a lot of those practices, good practices that they're talking about with regenerative agriculture, I think are very helpful to hemp production. And again, I think that's a good, if we can, make the economics of it work for people, could be a good crop as part of a rotation in our, typically smaller, diverse farming systems that we think are going to be economically sustainable here in Connecticut. As we look at this, of course, here you've got your topsoil layer. So the brown here is because of the organic matter in here. And then what the other properties we're looking for is we're looking at the soil structure. So how does it hold together in in the little bits. What you'd want to see is, you know, something like that where it has this kind of crumbly structure, looks like cake crumbs or cookie crumbs. That's all the, you know, the microflora in the soil, and all of the little glues that they create these little structures in the soil. So that makes it easy for the roots to penetrate. The other thing you're looking for is potential for compaction. So does it feel hard when you're walking on it? You know, as you dig down, is it hard to dig down through? And then the other thing you can do is just have a, like, one of the metal wire flags that people would use for marking a boundary of something. Just poking into the soil. If you can poke it down in fairly easily, first, you know, there's always a lot of rocks and stones,
Sure.
but between those, then it means you probably don't have compaction. And again, you know, the worst thing is having heavy equipment on a soil when it's wet, or over tillage or breaking up the structure. So we're going down through the topsoil layer into, you can start to see the colors just starting to change into the subsoil. And you've got just a little bit of compaction here. It feels a little firm, but it's not what I would call, you know, something that certainly could be broken up easily with tillage, or just, you know, you'll get a little bit of benefit of freeze thaw. Also, you know, cover crops can help with that, particularly cover crops with tillage radishes. So the other thing you would see that would indicate a little bit of compaction is if it starts to break apart into like plates. So you can see it's just starting to break apart into a plate just a little bit. So there's just a little bit of compaction there. So if it's really platey, that would be an indication that you have compaction. So you can see how you have that nice yellowish brown color. So that's the subsoil layer. It's still kind of a fine sandy loam texture to it, which again, as I said, holds moisture, holds nutrients pretty well. We use this auger to go a little bit deeper, although I know everybody likes to see somebody else dig a hole. That's always fun. And the other thing that, as a soil scientist, that indicates to me that this is a well-drained soil, meaning that it's not saturated during the growing season, is this subsoil layer below the topsoil had this nice yellowish brown color. So the sand and silt grains are coated with oxidized iron. So if it were a soil that was saturated during the growing season significantly, it would be darker, grayer colors. And the grayer colors basically means that the iron, it's been in anaerobic conditions, and the iron actually gets washed off those coatings and dissolved into the soil water, and then moves off the landscape. So we still have this nice yellowish brown color, and we have this is actually a little bit finer textured, like a fine, almost a very fine sandy loam texture. Dirties your fingers a little bit, but you can still feel a little bit of grit. You can hear a little bit of grit if you put it up to your finger. Holds a nice amount of moisture. So there's just got this little terrace of sandy, loamy soils here, but very close to the river. And again, we're getting through the subsoil into what we would call the substratum, which is the lowest part of the soil profile. There's very few stones or rocks here. So from, you know, a standpoint of having to plant seeds or plants and use equipment on it, it's easy. So here we're getting a major change. I'm probably getting close to some sand and gravel deposits here. You can see it's getting a little bit grayer, darker in color, but that's not because it's wet. It's because you're getting below where most of the biological activity is that forms our soil. So it looks much more like when the glacial meltwaters, you know, laid it down. It hasn't what we would call a lot of soil development. Yep, I'm just starting to get into a little bit of see, there's a little bit of gravel here, a little bit of some rotted rocks there, and we definitely have, you know, over 24 inches of nice soil material for a rooting zone. Typically, most of our rooting zones aren't any deeper than about 40 inches. I know that supposedly hemp can have a very deep taproot
Yeah,
to it,
yeah.
but in general, particularly those soils that I talked about that are the soils that formed in drumlins, or people call them hard pan soils, they have a restrictive layer at about 24 to 36 inches. So it limits the root depth. So that's something to keep in mind if you're farming those soils. So in a dry year, sometimes they'll actually hold a little bit moisture because it perches on top of that pan, but in a wet year, it can be a challenge to get on them to do the field work and do the planting that you need. So here, yeah, so here we've got a good 30 inches of soil material that's very suitable for rooting. And so I would think that you know, a hemp plant would do well on these soils. The other thing is, as the soil gets sandier, is that, you know, there is the potential, because the nutrients really get held on the organic matter and on the silt and clay particles, not on the sand particles, or not as chemically charged. So think about, again, doing a soil test, but doing a split application of some sort. And then also really watch the weather. You know, if you know there's going to be a big weather event, don't be fertilizing, you know, the day before we're going to get, because instead, when we used to get 1 inch of rain, now we get 2 or 3 inches of rain. You don't want it all to wash away, to leach through the soil. So I think split applications can be very helpful as far as managing, particularly your nitrogen applications. And then, you know, part of it is the soil, part of it is also the setting as well. Certainly, you know, our floodplains have some very productive soils, and there are higher terraces of our floodplains along all of our major rivers that have a little bit of a microclimate, some excellent soils. The one thing that I would have concerns about is to make sure that you have adequate airflow, because they can be, sometimes with small ones, they can be frost pockets on smaller floodplains. Let me just turn this off, sorry about that. And then also to be able to, you know, limit, you may need to clear some trees or clear some brush along the edges so you have good airflow through the fields, so that you don't end up having some of the disease problems. So I don't know if you have any other thoughts or questions, but again, you know, I would encourage everybody to consider the soils first, and that the soil management is going to be the best way to have, you know, healthy plants that are going to need, you know, less nutrients and less attention to pests and diseases.
Outstanding.
Great, thank you for the opportunity.
Kip, thank you. Thanks for joining us.
Sure.